Hello students, welcome to our class on inorganic polymers. In this class, we are going to discuss the phosphorus-nitrogen compounds. Phosphorus-nitrogen compounds, the important class of phosphorus-nitrogen compounds are phosphazines or otherwise known as phosphor-nitric compounds. These are the compounds containing phosphorus-nitrogen bonds. In these compounds, phosphorus is in +5 oxidation state and nitrogen is in the +3 oxidation state. Phosphazines or phosphonitric compounds can be cyclic or acyclic. If it is cyclic, it is known as cyclophosphazine or cyclophosphonitric compounds. It has the general formula PNR2N times, where R is halogens like fluorine, chlorine, bromine, or other thiocyanate groups, alkyl or aryl groups, or ethoxy or methoxy group. It is an example for cyclotriphosphaline, cyclic compound. It is a cyclic trimer because it contains 3 PN bonds or 3 PNR2 units. It is a cyclic trimer, and in which it's this cyclic trimer, the ring is planar just like or benzene. Okay, but in higher compounds like a cyclic tetramer, it is a cyclic tetramer. In this ring is not planar, it is puckered, that is it is deviate from the planarity. Then acyclic compounds, it is a linear molecule. There are different types of acyclic phosphazines are there. There are monophosphazines. The general formula is R3P double bond N R dash. Here also R and R dash are halogens, alkyl, aryls, etc. Then another one is diphosphazines with the general formula R4PN double bond P R3 dash. Examples: C6H5 4 times P N double bond P CF3 thrice. Here the R group is a phenyl group. This is tetraphenyl. These 4 R groups are phenyl groups. Here the R dash group is trifluoromethyl group. Okay. Then another class of acyclic phosphazines is polyphosphazines. It is a polymer with a PN backbone. That is, the backbone of the polymer is made up of phosphorus and nitrogen. Then R group is R or R dash may be halogen, alkyl, aryl, etc. It is the structure of polyphosphazines. Then another one is the chlorophosphazine. It is an important class of compounds of phosphazines. When in phosphazines, when R is equal to, these are the phosphazines. In this phosphazine, and R is equal to a chlorine, it is known as chlorophosphazines or phosphonitric chlorides. The general formula is PnCl2 n times. That is, here in phosphazine, the R is replaced by chlorine. Here n is equal to 3 to 11. If n is equal to 3, it is the trimer. Okay, cyclic trimer. It is an example for cyclic trimer, that is hexachlorotriphosphaline. Hexachloro means there are total 6 chlorine atoms that are each chlorine atom is bonded to phosphorus. Okay, so it is a hexachlorocyclotriphosphaline. In this, the NPN bond angle is about 120 and the CL-PCl bond angle is 108. The nitrogen is in the, all nitrogens are in the sp2 hybridized state and phosphorus are in the sp3 hybridized state. The PN ring is planar, but the chlorine atom is not planar to the plane of the ring. The in every phosphorus, one chlorine atom is above the plane of the ring and one chlorine atom below the plane of the ring. That is, there are out of 6 chlorine atoms, 3 chlorine atoms are above the plane of the ring, each at every phosphorus, and 3 chlorine atoms are below the plane of the ring. Then another one is the cyclic tetramer. The chlorine atom is bonded to the phosphorus. There are 2 chlorine atoms are bonded to each phosphorus. It is not a ring structure. It is not a cyclic. It is not a planar. But that is, it is the ring is just it is deviate from the planarity. Okay. Then the method of preparation of this cyclic trimer and cyclic tetramer is that PCl5 is react with ammonium chloride in the presence of tetrachloroethane. We can get a mixture of cyclic trimer and cyclic tetramer. Another compound class of compound is acyclic cyclophosphasin. Just like phosphazines or phosphor-nitrogen compounds, its chlorine derivatives are also cyclic and acyclic. Then acyclic chlorophosphazines, the general formula is Cl4p N PCl2 N N double bond PCl3. Here N is greater than or equal to 0. If N is equal to 0, that is, if N is equal to 0, this term, this part is absent. That is PCl4 single bond N double bond PCl3. This is the compound when N is equal to 0. When N is equal to 1, it is N, there is one unit of N double bond PCl2 is there. That is PCl4 N double bond PCl2 single bond N double bond PCl3. This is N is equal to 1. When N is equal to 2, this is here it is 2. There are 2 units of this. Then another one is this polyphosphor-nitrogen compounds. Polyphosphor-nitrogen compounds, the general formula is, that is polychlorophosins. This is the general formula of polychlorophosphine. That is N double bond PCl2 N times. The method how we can prepare this polymer, it is treated with, in this the PCl5 is treated with the ammonium chloride in the presence of tetrachloroethane. We can get a mixture of polymer, cyclic trimer, cyclic tetramer, and the byproduct is HCl. Here cyclic trimer and cyclic tetramer are soluble in petroleum ether, and this is not soluble in petroleum either. So we can easily easily remove or separate this polymer from this cyclic trimer and cyclic tetramer by fractional distillation or solvent extraction. Solvent extraction using petroleum ether. These two are dissolved in petroleum ether, but it is not dissolved in petroleum ether. So we can easily recover this polymer from the petroleum ether or precipitated polymer from the petroleum ether. Okay. The properties: freshly prepared polymer is soluble in chloroform but not soluble in petroleum ether. This property is used for the separation of this mixture. When allowed to stand, the polymer gets cross-linked and slowly is converted into a gel form. But when we allow to stand the polymer in chloroform, they become cross-linked, or the individual polymer chains become cross-linked through bonds, and it is converted into a gel form. It is known as the inorganic rubber because it has high elasticity. Rubber means they are elastomer, they perform elasticity. Elasticity means when we stretch the material by applying some force, it gets elongated to extent, and when we release the external force or applied force, it comes back to its original shape. Such compounds are known as elastic compounds. So the polychlorophosins, so high degree of elasticity, so they are known as inorganic rubber because they stretched several folds with almost recovery. They stretched many times of to its length. When we release the force or stretching force, it comes back to its original length. So it is a known as inorganic polymers. It undergo degradation under normal atmosphere. But one drawback or disadvantage is that it undergo degradation under normal atmospheric condition without any extreme condition. Even in the our normal atmospheric condition, it become degraded or it become converted into small molecules. So because of this drawback or limitation, it has not much commercial use. Okay, because it is easily degraded, it lost its property, so it is not recommended, or it is not suitable for any commercial purpose. These are the phosphorus nitrogen compounds and chlorophosphonitrile chlorides. Okay, I stop here. Study well. Thank you.